Hello guys, welcome once more to JAMB Physics 2020 question number 11 to number 15. My name is Mr. Damilola, and in this video you shall be having a nice time learning some wonderful things in physics that will help you in your journey. Now don't forget to like our video. If you like this video, to click on the like button and to subscribe and to tell your friends about this video so that they can also learn as you are learning, because we have loads of contents to share with you that will help to simplify. All you have to do in physics is to just have enough exposure. It's not because it is difficult, it's just exposure you need. With enough exposure, you won't have a single problem solving your questions in your exam in physics. Now let's check out number 11. Number 11 question says this: natural radioactivity consists of the emission of what? Now, in our previous video, we've spoken about radioactivity, and we spoke about three types of radiation: alpha, beta, and gamma. Now, and that means that naturally we will know that the answer to this question, we can't say that natural radioactivity is just alpha and beta radiation only. No. Then we can say alpha particle and gamma. That's X-ray. That's also wrong. It's not also gamma. That's why it symbolizes gamma. Gamma and X. That's also wrong. Then alpha, beta, and gamma. D is therefore the correct answer. So all the radiations in natural radioactivity is alpha radiation, beta radiation, and gamma radiation. And for a quick reminder, remember that alpha radiation is positively charged. It is made up of 2 protons and 2 neutrons. Then beta radiations are made from electrons, that's negatively charged particles, while gamma radiations are electromagnetic materials. So those are just a quick summary of what they stand for and what they do. Okay, so natural radioactivity is made up of alpha, beta, and gamma radiation, making question number 11 the answer to be option D. Now let's check out number 12. That's very easy. Now 12 says, if a source of sound, please, is moving, a stationary listener will hear a sound of different frequency. This is called A, Doppler effect; B, resonance; C, ultrasound; D, rarefaction. Now, what do you think is the answer to that question? Do you have any idea? Okay, now let's take a look at it. Now, the source of sound is moving. It's like you have a moving vehicle. Let me use a picture to explain that. If a vehicle is moving, okay, the source of sound is moving, a stationary listener, that's somebody who is passing by the road or standing in a place, okay, will hear the sound of different frequencies. In sound wave, when frequencies are different, it has an implication on pitch. Okay, that means as the car is moving away from the first guy, that's the man, and moving towards that fine girl in the picture there, the sound is going to be increasing. That means the pitch of the sound will get higher. Okay, what I'm saying is that as the sound is moving from the fine boy to the fine girl, the pitch of the sound, because of the difference in frequency, the frequency will intensify in a direction, but the frequency will reduce in his direction because the car is moving away from him. So that is the diagram of the movement of the frequency between them. Okay, so that is the first option says Doppler effect. Doppler effect means change in perceived sound frequency due to relative motion of sound source, and that means that the answer to that question is simply the Doppler effect. So Doppler effect is simply defined as the change in sound frequency, okay, due to change in position or in relative position of sound source. If you can get that formula, you have really known Doppler effect, and you must know it because most theory questions ask about Doppler effect. Okay, they might just say define Doppler effect, and then explain the relationship why sound towards a particular source is getting louder but getting lower towards the second source. So the quick explanation is the Doppler effect, and that diagram explains the movement. It is due to increase in frequency, difference or variation in frequency. Now, another option that I would like to explain, which is not the answer is Doppler effect, but I would also like to explain the other options. We have resonance. Resonance is when a vibrating body forces another body to move with its own natural frequency. A practical example of resonance is when you have, and some of us have, have you ever seen a chime before? Chime. Chime has to do with different metals arranged side by side. Different metals, like metallic rod, arranged beside themselves. Then you strike one, boom. Then the first one is the second one and make it to vibrate with its own frequency. That means the first one transfer its frequency to the second one. That is a good example of forced vibration or resonance. Okay, so that's resonance. Then let's talk about ultrasonic sound. Ultrasonic sound is the sound that is too high for the human ear to pick. Now, the human ear can only hear sound between 20 to 20,000 Hz. Now, any sound above 20,000 Hz is too high for the human ear to hear, and that is called ultrasonic sound. Things like dog can hear that. Animals with long ears, like dog, cat, they can hear ultrasonic sound, but we can't hear ultrasonic sound. So that's ultrasonic sound, and that's not the answer to the question. Then rarefaction is reduction in density of a wave or substance. So because expansion reduces density, when something reduces, it gets denser. But when it expands, the density gets lower. Okay, so reduction in density, that is called rarefaction. Reduction in density of wave is called rarefaction, and that is rarefaction. Now, but the answer to this question is the Doppler effect, and that settles number 12, the Doppler effect, making option A the correct answer. Now, let's take out number 13 now. Which of the following can be described as a high tension transmission? Now, when you hear the word high tension, think of your transformer. Nobody touched the transformer. It is an electric field unless the person wants to get shocked to death. So that person will be electrocuted. Now, but really, high tension is not transformer. High tension are those giant electric towers or metallic structures that carry the long wire. When the wire is coming from the plant where electricity is being generated. I have a picture of that here. You can see that there. So we have high tension transmission system are transmitting. Now, the implication, now the question said the implication that which of the following is possible with high tension? It has huge resistance and low voltage, low current and high voltage. Now, high current and low voltage, or high current and low resistance. Now, for you to be able to transmit electricity on that high tension, the one that comes to your house is low tension. It must have been stepped down by your transformer. The function of the transformer is to step down current. It is because the way it comes from the plant where it is being made, the way it comes from the plant where it is being made, it is high. If you send it to the home directly, it will explode everything in your house. So it has to be stepped down, tempered down by a transformer. So that's the work of a transformer. It tempers it down. But the kind of current in the high tension, what kind of current is it? Is it low current or high current or high voltage or high and so on? So let's check it out. Now let's just learn it down. Now, high tension transmission, this requires for electricity to move in high tension, it requires high voltage and low current for it to be efficient. Now that means the kind of electricity in high tension is that which has high voltage and low current. I'll come again. Don't forget that voltage must be high for electricity to move in high tension transmission system. The voltage must be made very high and the current must be made very low, and that makes it to move faster. But I must also say this now, although the question didn't ask that. When it is coming to your house, it has to become low tension transmission. That means that the current must be made high and the voltage must be made low. Do you get that now? So high tension use high voltage and low current, but low tension coming to our homes use low voltage but high current. So the answer to that question is simply option B, low current and high voltage, and that's what makes high tension work. Now let's check number 14. What is cost of running 50 watt lamp and 400 watt lamp for 10 hours if electrical energy costs 2 kobo per kilowatt hour? Now when you talk about cost, if you don't know cost, physics want you to know cost, but if you don't know cost, then you won't know how NEPA charge you or how the power company charge you, how they charge you. Now physics, if you've studied physics, you must have been taught that, and physics want you to know that. So science will explain that to you. Now they charge you by the amount of watt you use multiplied by the amount of time you have used it multiplied by the rate they charge per watt. Okay, if you don't get that, don't worry about that. We will get it in the working. So I said electrical cost is watt consumed. That's the amount of power you have used times the time times the unit cost. You know, NEPA have their own. Every company has their cost per watt that you are using. So that's the unit cost. So the solution to that question is watt consumed is therefore, you know, we have 550 watt lamp. So that's the lamp 50 watts. That's 5 times 50 plus we have 400 watts. That's 4 times 100. So that's 5 times 50 is what, 250 plus 4 times 100 is 400. Plus it together, you have 650 watts. Okay, then the time, that's the power. That's 650 watts is the power. Then the time is 10 hours. Then the total energy consumed is the product of the power and the time. That's 650 times 10, and that gives me 6,500 watts is the amount of energy the person consumed. Okay, now, but it can't be in watt. You must now change it to kilowatt. Now, it can't be calculated in watt. It must be in kilowatt. So to change from watt to kilowatt, you use 1,000 to divide it. That will become 6,500 divided by 1,000, giving me 6.5 kilowatts. Okay, kilowatt. That's supposed to be kilowatt, not kilowatt hour. So that is it, and that's the unit there. Actually, it's supposed to be kilowatt hour because I have included time. It's supposed to be kilowatt hour. So it is 6.5 kilowatt hour. Now, it remains the unit cost. Now, the unit cost in the question is 2 kobo. So 6.5 times 2, and that makes me, and that gives me 13 kobo. But in naira, if you have to divide, that means you will have to divide kobo by 100. You know, 100 kobo make 1 naira. So to make it naira, you just say 13 kobo divided by 100, and that will give you 0.13 naira, and that is my answer. Now this is very straightforward. It is just power, watt times time times unit cost, and you must use the right unit. You know, the power must be, you must divide by 1,000 to make it kilowatt hour. Okay, and the unit cost must be in naira, as in most cases it is. So the answer there is 0.13 0 naira 13 kobo, and that is my answer, making option D the correct answer to number 14. Now let's check out the last one for this video, number 15. It says the mass of proton is approximately equal to that of what? Now, proton mass for a neutral atom is equal to that of what? Now, you know, you can remember the atomic structure. Proton is positive, neutron is neutral, that means it has no charge, and electron is negative. So proton is positive, neutron has no charge, and electron is negative. But the mass, if we talk about mass, proton and neutron are inside the nucleus of an atom. That means they are inside the inner core. Okay, but electron moves around, and we have been told that it is only proton and neutron that have mass, and they have the same mass. They have 1, 1. Their masses are 1, 1, approximately the same, 1, 1. Okay, approximately 1, 1. Okay, but electron has no mass, so that means electron mass is 0. That means it has no mass. So electron does not have mass. So the answer, the question said the mass of proton is approximately equal to that of neutron. So the answer is therefore not alpha particle, not beta particle, it's just neutron. This is a subatomic particle and this is an atomic question. So it is neutron, not electron, but neutron. So that brings us to the end of this video. Don't forget to like the video if you really enjoy the video, so that you can get more content from us from time to time, where we explain physics in a way that anybody, even a crybaby, can understand. Okay, so until we see next time, guys, take care of yourself. Bye for now.